we will study about the techniques for finding mean, median and mode of group data. We will also learn about cumulative frequency graph of a frequency distribution. Mean of group data. If x1, x2, x3, so on to xn are n values of a variable x, then the arithmetic mean or simply mean of these values is denoted by x bar and is defined as x bar is equal to x1 plus x2 plus x3 plus so on to plus xn upon n, or x bar is equal to summation I is equal to 1 to n xi upon n. Here the symbol denotes the sum x1 plus x2 plus x3 plus so on to plus xn. In a discrete frequency distribution, the arithmetic mean may be computed by any one of the following methods: direct method, shortcut method, step deviation method. Direct method.
Let us take an example. Find the mean of the following distribution: x 4, 6, 9, 10 and 15, f 5, 10, 10, 7 and 8. The solution is calculation of arithmetic mean. xi is 4, 6, 9, 10, 15. fi is 5, 10, 10, 7, 8, where n is equal to sigma fi is equal to 40. fi xi is 20, 60, 90, 70, 120, where sigma fi xi is equal to 360. Therefore, mean is equal to x is equal to sigma fi xi by sigma fi, which is equal to 360 by 40, which gives 9.
Variate x takes values x1, x2, so on to xn with corresponding frequencies f1, f2, f3, so on to fn respectively. Then arithmetic mean of these values is given by x bar is equal to f1 x1 plus f2 x2 plus so on to plus fn xn upon f1 plus f2 plus so on to plus fn, or x bar is equal to summation I is equal to 1 to n f1 x1 upon n, where n is equal to summation I 1 to n f1 is equal to f1 plus f2 so on to plus fn. Shortcut method.
Let us take an example. The following table shows the weights of 12 students. Weight in kg are 67, 70, 72, 73 and 75. Number of students are 4, 3, 2, 2, 1. Find the mean weight by using shortcut method. The solution is, let the assumed mean be A is equal to 72. xi is equal to weight in kg and fi is equal to number of students. Calculation of arithmetic mean. Xi is 67, 70, 72, 73, 75. Fi is 4, 3, 2, 2, 1, where n is equal to sigma Fi is equal to 12. Di is equal to xi minus a, which is equal to xi minus 72, which is minus 5, minus 2, 0, 1, 3. Fi di is minus 20, minus 6, 2, 2, 3, where sigma Fi di is equal to minus 21. We have n is equal to 12. Sigma Fi di is equal to minus 21 and a is equal to 72. Therefore, mean is equal to a plus 1 by n Sfi di, or mean is equal to 72 plus minus 21 by 12, which is equal to 72 minus 7 by 4. Mean is equal to 288 minus 7 by 4, which is equal to 281 by 4, which is equal to 70.25 kg. Hence, mean weight is equal to 70.25 kg. Let us take an example for illustration. Number 1. The following are the marks of 9 students in a class. Find the median. 34, 32, 48, 38, 24, 30, 27, 21, 35. Number 2. Find the median of the daily wages of 10 workers from the following data: rupees 20, 25, 17, 18, 8, 15, 22, 11, 9, 14. The first solution is: arrange the data in ascending order of magnitude. We have 21, 24, 27, 30, 32, 34, 35, 38, 48. Since there are 9, that is an odd number of items, therefore median is the value of 9 plus 1 by 2th observations, that is 32. We have 8, 9, 11, 14, 15, 17, 18, 20, 22, 25. Since there are 10 observations, therefore median is the arithmetic mean of 10 by 2 and 10 by 2 plus 1th observations. Hence, median is equal to 15 plus 17 by 2, which is equal to 16.
Median is the middle value of a distribution. That is, median of a distribution is the value of the variable which divides it into two equal parts. It is the value of the variable such that the number of observations above it is equal to the number of observations below it. Algorithm. Step 1. Arrange the observations x1, x2, so on to xn in ascending or descending order of magnitude. Step 2. Determine the total number of observations, say n. Step 3. If n is odd, then median is the value of n plus 1 upon 2th observation. If n is even, then median is the AM of the values of n by 2th and n by 2 plus 1th observations. Medium of discrete frequency distribution. Discrete frequency distribution xi upon fi, where I is equal to 1, 2, so on to n. We calculate the median by using the following algorithm. Step 1. Find the cumulative frequencies, that is CF. Step 2. Find n by 2, where n is equal to summation I is equal to 1 to n fi. See the cumulative frequency, that is CF, just greater than n by 2 and determine the corresponding value of the variable. Merits and demerits of median. The following are some merits and demerits of median. Merits. It is easy to compute and understand. It is well defined and ideal average should be. It can also be computed in case of frequency distribution with open-ended classes. It is not affected by extreme values. It can be determined graphically. It is proper average for qualitative data where items are not measured but are scored. Demerits. For computing median data needs to be arranged in ascending or descending order. It is not based on all the observation of the data. It cannot be given further algebraic treatment. It is affected by fluctuations of sampling. It is not accurate when the data is not large. In some cases, median is determined approximately as the midpoint of two observations, whereas for mean this does not happen.
Definition of mode for a continuous frequency distribution. Let us take an example. Find the mode of the following data: 120, 110, 130, 110, 120, 140, 130, 120, 140, 120. Solution. Value of xi are 110, 120, 130 and 140. Frequency fi are 2, 4, 2, 2. We observe that the value 120 has the maximum frequency. Hence, the mode or modal value is 120.
Or model value of a distribution is that value of the variable for which the frequency is maximum. Thus, the mode of a distribution is that value of the variable around which the values of the variable are clustered densely. Computation of mode of a series of individual observation. In order to compute the mode of a series of individual observations, we first convert it into a discrete series frequency distribution by preparing a frequency table. From the frequency table, we identify the value having maximum frequency. The value of variable so obtained is the mode or model value.
Computation of mode for a continuous frequency
Of mode
distribution.
for a continuous frequency distribution. Let us take an example. Size of items are 0 to 4, 4 to 8, 8 to 12, 12 to 16, 16 to 20, 20 to 40, 24 to 28, 28 to 32, 32 to 36, and 36 to 40. Frequency is 5, 7, 9, 17, 12, 10, 6, 3, 1, 0. The solution is where L is equal to lower limit of modal class, H is equal to width of modal class, F is equal to frequency of modal class, F1 is equal to frequency of the class preceding the modal class, F2 is equal to frequency of the class following the modal class. We have L is equal to 12, H is equal to 4, F is equal to 17, F1 is equal to 9, and F2 is equal to 12. Mode is equal to L plus F minus F1 by 2F minus F1 minus F2 into H. Mode is equal to 12 plus 17 minus 9 divided by 34 minus 9 minus 12 into 4. Mode is equal to 12 plus 8 by 3 into 4, which is equal to 12 plus 10.66, which is equal to 32.66.
For grouped or continuous frequency distribution with equal class intervals, we use the following algorithm to compute the mode. Algorithm. Step 1. Obtain the continuous frequency distribution. Step 2. Determine the class of maximum frequency either by inspection or by grouping method. This class is called the modal class. Step 3. Obtain the values of the following from the frequency distribution. L is equal to lower limit of the modal class. F is equal to frequency of the modal class. H is equal to width of the modal class. F1 is equal to frequency of the class preceding the modal class. F2 is equal to frequency of the class following the modal class. Step 4. Substitute the values obtained in step 3 in the following formula. Mode is equal to L plus F minus F1 upon 2F minus F1 minus F2 into H. Merits, demerits and uses of mode. The following are some merits and demerits of mode. Merits. It is readily comprehensible and easy to compute. In some case, it can be computed merely by inspection. It is not affected by extreme values. It can be obtained even if the extreme values are not known. Mode can be determined in distributions with open classes. Mode can be located on graph also. Demerits. It is ill-defined. It is not always possible to find a clearly defined mode. In some cases, we may come across distributions with two modes. Such distributions are called bimodal. If a distribution has more than two modes, it is said to be multimodal. It is not based upon all the observation. Mode can be calculated by various formula. As such, the value may differ from one to other. Therefore, it is not rigidly defined. It is affected to a greater extent by fluctuations of sampling.
Uses of mode. Mode is used by the manufacturers of ready-made garments, shoes, and accessories in common use, etc. The ready-made garment manufacturers made those sizes more which are used by most of the persons than other sizes. Similarly, the makers of shoes will make that size maximum which the majority people use and others in less quantity.
Mean, median, and mode. These three measures are closely connected by the following relations. Mode is equal to 3 median minus 2 mean, or median is equal to mode plus 2 upon 3 mean minus mode, or mean is equal to mode plus 3 upon 2 median minus mode. Cumulative frequency polygon, curve and ogive. The technique of drawing the cumulative frequency polygons and cumulative frequency curves or ogives is more or less the same. The only difference is that in case of simple frequency curves and polygons, the frequencies are plotted against class marks of the class intervals, whereas in case of a cumulative frequency polygon or curves, the cumulative frequencies are plotted against the lower or upper limits of the class intervals depending upon the manner in which the series has been cumulated. There are two methods of constructing a frequency polygon and an ogive. Let us now discuss the two methods. Less than method, more than method. Less than method. To construct a cumulative frequency polygon and an ogive by less than method, we use the following algorithm.
Frequency.
Draw an ogive and the cumulative frequency polygon for the following frequency distribution by less than method for table 1. We first prepare the cumulative frequency distribution table by less than method as shown in table 2nd. Now, we plot the points 0, 0, 10, 7, 20, 17, 30, 40, 40, 91, 50, 97 and 60, 100. Now we join the plotted points by line segments as shown in figure.
Cumulative frequency curve.
Draw a cumulative frequency curve and cumulative frequency polygon for the following frequency distribution by less than method for table 1. The given frequency distribution is not continuous, so we first make it continuous and prepare the cumulative frequency distribution as shown in table 2. Now we plot points 9.55, 19.5, 20, 29.5, 40, 39.5, 63, 49.5, 80, 59.5, 91 and 69.5, 100. The cumulative frequency polygon is obtained by joining these points by line segments.
Cumulative frequency curve.
Following is the age distribution of a group of students. Draw the cumulative frequency polygon, cumulative frequency curve, and hence obtain the median for table 1. We first prepare the cumulative frequency table by less than method as given in table 2. We plot the points 50, 640, 796, 8 156, 9 222, 10 306, 11 402, 12 494, 13 574, 14 638, 15 682, 16 702, and 17 710. These points are marked and joined by line segments to obtain the cumulative frequency polygon.
Step 1. Start with the upper limits of class intervals and add class frequencies to obtain the cumulative frequency distribution. Step 2. Mark upper class limits along x-axis on a suitable scale. Step 3. Mark cumulative frequencies along y-axis on a suitable scale. Step 4. Plot the points xi, fi, where xi is the upper limit of the class and fi is the corresponding cumulative frequency. Step 5. Join the points obtained in step 4 by a freehand smooth curve to get the ogive, and to get the cumulative frequency polygon, join the points obtained in step 4 by lens segments. More than method. To construct a cumulative frequency polygon and an ogive by more than method, we use the following algorithm.
Distribution of scores obtained by 230 candidates in a medical entrance test is as follows in table 1. Draw cumulative frequency curves by less than and more than method on the same axis. We first prepare the cumulative frequency table by less than method as given in table 2. Now we plot the points 400 0, 450 20, 555, 550 195, 600 127, 650 151, 700 178, 750 198, and 800 230. In order to obtain the cumulative frequency polygon, join these points by line segments. Now we plot the points 400 230, 450 210, 500 175, 550 175, 600 103, 650 79, 761, 750 27, and 800 0. The cumulative frequency polygon by more than method is obtained by joining these points by line segments.
Step 1. Start with the lower limits of class intervals and from the total frequencies subtract the frequency of each class to obtain the cumulative frequency distribution. Step 2. Mark the lower class limits along x-axis on a suitable scale. Step 3. Mark the cumulative frequencies along y-axis on a suitable scale. Step 4. Plot the points xi, fi, where xi is the lower limit of a class and fi is corresponding cumulative frequency. Step 5. Join the points obtained in step 4 by a freehand smooth curve to get the ogive, and to get the cumulative frequency polygon, join these points by lens segments.